Mixed mode DC power supply stability assessments when using remote sense. To demonstrate oscillations during remote sensing, we connected a power supply and electronic load using 3-meter wires. 2 parallel 22 microfarad capacitors were also connected at the electronic load. We then tested several different power supplies, checking for oscillations on the output using an oscilloscope. The connection diagram is shown on the next page. Remote sense oscillation, testing with power supply 1. A pair of 3-meter twisted wires is connected. The electronic load is set to 4 amp constant current. The output of the power supply under test is set to 3.3 volts and a current limit of 5 amps. We can see an oscillating waveform with a frequency of 10 kHz and 400 millivolts of amplitude on the oscilloscope. Power supply remote sense oscillations, testing with power supply 2. The output of the power supply is set to 3.3 volts and a maximum current of 7.21 amps. We can see an oscillation in the output voltage waveform at about 10 kHz and 300 millivolts. Power supply remote sense oscillation testing with power supply 3. The output of the power supply is set to 3.3 volts and a maximum current of 7 amps. We can see an oscillation in the output voltage waveform of just over 18 kHz and 500 millivolts on the oscilloscope. Power supply remote sense oscillation test 4 using the Picotest P9610A. The output of the power supply is set to 3.3 volts and a maximum current of 7.35 amps. Notice there is no oscillation in the output waveform on the oscilloscope. To increase the probability of oscillation, we increased the wire length from 3 meters to 8 meters. Note that the added impedance still doesn't cause the P9610A power supply to oscillate. In conclusion, after testing, we found that 3 commonly used power supplies oscillate when a 3-meter remote sense lead was connected. The P9610 does not show any oscillations even with a cable of 8 meters. The P9610A has much better stability than the other power supplies tested.